Characterization of flaws with UT is hard enough. It's even harder with a 70-degree probe. When I first started in UT, I used to hate the 70-degree probe because the beam spread is so wide. It's nothing like that needle-like response you get from a 45-degree. But with a lot of the weld thicknesses we have to test with UT, you're kind of stuck with a 70. When we're scrubbing a weld and looking at that echo dynamic, trying to pick out all those little bits and pieces of the signal, what we're doing is really drawing long, skinny triangles. And the higher the angle, the longer and skinnier the triangle is. And what that means is that one part of the flaw here and another part of the flaw there, look at those line lengths. They're almost the same. That means when you look at it on your A scan, those two parts of the signal may be smashed right together, so close you may not be able to tell them apart. And if you're able to use a lower angle, there's your advantage because the differences between those sound paths become greater and you can tell the difference on your A scan, easier characterization. This means that a 70-degree can be tricky for flaw characterization. So we're going to take a look at a flaw tech plate and I'll show you what I mean. The first flaw is lack of root fusion. It's really easy to find as I move the probe back and forth. That's kind of obvious as I go like this and kind of wiggle the probe and try to get the response to get peaked. You can see there is actually two competing peaks right there, but they're so close together with this 70 because those line lengths are so similar at this high angle. It's really difficult to tell them apart and try to characterize this properly. To plot the position of this flaw in the X direction, I'm just going to move this back and forth until I kind of peak one of those signals right about there. I like. So then we'll see how far away from the weld center line are we. We're pretty much right on an inch. So what we're going to do is go over here and go over to our A scan. We're going to move this right over to about 1 inch, about right there. And you can see that it's plotting on the opposite side of the weld right over there, which is exactly where it's supposed to be. Detection with the 70-degree, that was fairly easy, but it's the characterization and sizing that's difficult. The second flaw is a root crack. And right away you can tell it's really hard to tell the difference between this and that lack of root fusion. And the reason for that is that both of these are essentially the same shape. You've got something which is connected to the back wall. It's going to give you that corner trap signal. And then there's going to be a little bit of a tip diffraction, maybe on the first leg and maybe on the second leg. Both of those do that. So it's really hard to tell the difference at this angle, especially. The last flaw on the plate is a lack of root penetration. If I flip the plate over, you can see it's just kind of a missing strip of weld right in the middle. And again, the response at 70 degrees, the echo dynamic looks almost exactly the same as the lack of root fusion and the root crack. Now we'll switch over to a 60-degree wedge. Back to the first flaw, that lack of root fusion. It's really easy to see here. And as I move the probe in and sort of oscillate it and twist it back and forth, you can now see we have a much clearer separation between the corner trap and that tip diffraction. The next flaw was the root crack on this side of the weld. And as I move it up, you can see there's the root signal and then, whoa, there it goes. Okay, so you can tell right away that it's closer to the probe because it's more to the left of the screen, which means that it's going to be on the right-hand side of the weld where I've got it right here. But look at that response. First of all, there's a tip, there's the corner trap. If I move the probe up a little bit, there's the other tip just out in front. Sometimes the 60 degree is a bit of a liar because what happens is you get a mode conversion effect. When you've got a perfectly vertical flaw, 60 degrees tends to mode convert, and what's going to happen is that that corner trap is not going to plot where you want it to. I will do a video later to better illustrate this. I'll probably use the photoelastic camera. Just be careful about mode conversions on a 60. The last flaw was lack of root penetration. Now you can tell as I move the probe into the flaw, those two signals pop up before the root signal. Root signal, indications from the flaw. So you can tell that's coming in earlier. And what that is the corner trap off of the lack of root penetration and then a little reflection or diffraction around the tip. The response off of weld flaws can change drastically with angle. And that's why characterization is so difficult with conventional UT. So when you can, try to hit it with a different angle. I hope you enjoyed the video. If you did, please hit the like and subscribe buttons, and thanks for watching.